Good afternoon, everybody. Thanks for joining in. I think we'll start the session now. So my name is Jerry Paul. I'm a product consultant here at Redington Value. We are the exclusive distributors for Tableau in the region, and our footprint spans across Middle East and Africa. So today we will talk a little bit about advanced analytics with Tableau. Uh, it's uh, it's worthwhile to note that we hold these sessions on a monthly basis, and we encourage all of you to participate with us in these sessions that we will be hosting in the coming months as well. Yeah. So without much delay, I'll jump right into the content. So today's agenda, like I mentioned, or rather, what you'd be able to grasp would be to identify use cases suiting your scenario, irrespective of whether you're a partner or a customer, whether it will fit your Tableau use case with advanced analytics, right? And in the course of this session, I'll try to take you through a demo of how you could use Tableau to complement your other analytical platforms that leverage advanced analytics, machine learning, and data science. So again, back to the agenda, we'll talk a little bit of advanced analytics and when exactly is it that you companies and organizations use advanced analytics to their benefits, right? And obviously, I'll take you through the demo, and we can close with a Q&A session as well, if you have any questions for that matter. All right. So the question is, when is an ideal scenario where you use advanced analytical concepts? When we say advanced analytics, again, it has got a lot to do with data science and machine learning. Now, these are buzzwords in the market. Businesses are craving for having data scientists and statisticians in their teams to get the right insights. So, if you were to look at this particular visual, right, which sort of tells you the journey of your analytics cycle end to end. The very first crux of it is descriptive analytics. So basically, you would want to understand what has happened in the past. Uh, one good use case that I could think of is how's your profit been for a particular department or per particular unit in your organization in the last quarter or in the previous year, or you could even think of a YOY change, what has happened. So that falls under the descriptive analytics umbrella. Moving on from descriptive analytics, you have diagnostic and predictive analytics. This is where you really understand what's going on at the moment and what might happen, and you leverage diagnostic and predictive analytical capabilities with the platforms that you have. And towards the end of the cycle is where you have prescriptive analytics, wherein you prescribe and you sort of make your decision as to what to do in the coming quarters to make sure that your business doesn't hit a downfall. Now that's where many platforms come together, which can help your IT team, your data science team, to put out the data and tell a story that really makes sense, right? Now, when you talk about this advanced analytics scenario, Tableau can act as a very good platform that can complement your existing advanced analytics platform. And so, as to mention, we'll be talking about Python and R. And Robot is nothing but an analytics extension that we have with Tableau. I'm going to talk about it when I take you through the demo so that you'll relate to it better. Now, for those of you who aren't aware of the Python and R platforms, they are nothing but, okay, before I come here, they're nothing but statistics and machine learning platforms, right? You need a lot of you need a lot of in-depth knowledge to code with the data that you have, which is why you would turn to your data scientists and statisticians even for that matter. So one of the key highlights here where you could complement your existing platform with Tableau is in telling your story to your managers and business users. So even when you have these models built, which I believe you can relate to, at least in some of your projects that you deal with, you may have models out there that your team is working on, and they're trying to crunch the numbers, they're trying to build on the accuracies, and they're trying to get the right prediction scores. Now, if you can't tell or relate that with the business users or the key decision makers, then you're losing the message. That's where Tableau comes into the picture, and you can leverage the capabilities within Tableau to tell that story efficiently. If you had to look at the Gartner Quadrant, right? Since we talked about Tableau, R, and Python, Tableau per se is not a data science and machine learning platform. You don't see Tableau up there in the quadrant. But where Tableau could add value, like I mentioned, is when you complement it with your existing solutions. Some of the key players in this space is, I could name, like you can see TIPCO Software, Data IQ, Databricks, and so on. I assume some of you may be familiar with these platforms as well. So even before you start, trying to understand why you need to go with Tableau and the other platforms to address your advanced analytics scenario, it's always helpful and worthwhile to ask some discovery questions. What I mean by discovery questions is probably something like, uh, does your data or does your goal involve predictions or prescriptive analysis? Can the problem be solved using built-in features? And if not, can it be done using a programming language? Now, these are some of the questions that you need to discover even before you start working on a use case that involves advanced analytics. And of course, the last point, do you have the necessary data science and programming skills in your team to deal with such a scenario? And that's very important because I think most of you have read now there's a dearth of data science skills in the market. It's a hot job right now. It's well in demand. So it's always worthwhile to upskill yourselves on these platforms, right? One of the caveats that I'd like to mention, for those of you who are already aware of what Tableau Online and Tableau Server is, for Tableau Online users, it doesn't currently support or allow external analytics extensions, right? So we'll have to wait that out a bit. Probably in the future, Tableau may come up with that feature as well. All right. So before I just take you through some use cases, I just want to highlight the prerequisites that you would need to work with the data. Um, Firstly, you need to set up your RServe or TabPy. RServe is nothing but your R service running on your R server, and TabPy is nothing but your Python service running on your Python server, right? You need to start either of these services to work with them, or rather to integrate that with Tableau. At the end of the session, I'll share these links. These are useful links that will guide you as to how to install and start your R server TabPy, whether it's on Windows or Mac. So that shouldn't be an issue. And it's not really a difficult job. It's just 2 lines of code and that's it. You'll be up and running. All right. So just taking you to the examples that I have here. What you see here is my Tableau desktop. All right. Now this is the flagship product, the flagship platform for those of you who aren't really aware. What you're looking at is a use case of a company, a ride-hailing service, and especially we're looking at one of the units, which is the electric scooters in the cities. One example, real life example I could take here from where I'm based out of Dubai, is Kareem. So Kareem has recently, maybe not recently, but they do have these electric scooters and scooters lined up at certain stations, docked in stations, so that people can use those bicycles to get from place A to place B. As simple as that. If you were to look at this dashboard, what it really tries to analyze is how much of activity or how much of usage is happening across months with respect to the trip distance. So you would see that there is an increase in usage up in the month of August. And if I were to interact with the dashboard, it even tells me which one is the busiest station out of the many that you see in the map. Now, one of the reasons why it's important to know which is the busiest station is to is to maintain your load balance. When I say load balance, it means that you need sufficient amount of cycles docked at a particular station to meet the demand, right? So you need to have a good hunch of numbers as to how much bicycles to expect based on the trend that you see across the months, so as to say. Now, before I move on to showing you a Python and R and data robot, I'll initially take you through the analytics capabilities which are inbuilt in Tableau. So this doesn't require you to integrate or connect to external extensions, but all of that is inbuilt in Tableau. One of the very first things that I'd like to show you is nothing but explain data. And now Tableau has launched a year back. For example, if you look here in August, I can see that there's a huge rise in demand, and I can see that this particular station is the hottest among the others. So I could really look into what's actually happening behind the scenes, in the sense that why is that this station is particularly used by many users. Now, explain data within itself is a statistical tool that sort of explains and lists down the possible explanations as to why something is significant, statistically significant. Now, here it says that there is an extreme value, which in turn implies that there are many customers coming in during that time of the month at that particular station. This could be useful in a way, because this leads on to asking more questions, which could be taken up by the other teams also, right? I could even visualize the difference here. If I were to throw that station out, I could try to see which are the other stations which are busy as well. One of the key questions that you may ask is, okay, so why is that particular station at this point of time of the year really in demand? You could leverage explain data from here as well. This is how it opens doors for multiple questions. Explain data sort of helps you in answering those questions. Here it clearly tells you that the weather condition is really favorable for people to take the rides, which could be one of the significant factors as to why people opt for that particular month and that particular station as well. One of the advancements that Tableau has done, which is again inbuilt, is it allows the data science team, or whoever that is who's using or creating this, analyzing the data, to add in more factors, or rather add in more variables that sort of correlates to this data point, which can help you in understanding more explanations as well. So this was about explain data. Just wanted to give you a hunch of how that works. I encourage you to look at your data with Tableau and leverage explain data as well. Now, if you think from a business perspective, let's again take the example of a ride-hailing service. You may want to have or give different offerings to different customers. If you have 1 million customers, you obviously don't want to give the same offering to all of them, which means that you may want to profile these customers in a way and probably group them, let's say, into 5 groups or 5 profiles, and roll out 5 different offerings to them. So how do you do that? With the help of the existing machine learning algorithms in place, like clustering for that matter. We are able to profile these customers based on certain factors and then roll out the offers. If I were to show you an example here, let's say that I am looking at the total time rented by the customers, right? And I want to have a look at the number of rides that they have taken. I also have data regarding customer type that sort of tells me whether he or she is a subscriber or a casual customer, right? So here I can see that subscribers are actually spending way more time and traveling more compared to your casual users who leverage the facility. I could really think of adding more granularity, more details. Maybe I want to have a look at a station level. So I'll bring in my station details. If I look at my station details here, I'll just pull it into the visual. And I'll just drill down to station city, station location, and finally to station name, as you see here. Just a little bit of formatting. Yeah. So now each data point tells me from each station what's the total time that has been the bicycles have been rented, and how many rides have I gotten from each of these stations. Now, based on these two factors, these two variables, I'd like to profile my customers now. All I have to do right now is just go to my analytics pane, and you see a bunch of options here. And I'm going to pull in my cluster algorithm, which is inbuilt in Tableau. And I'm simply going to select that. And based on these two variables, I can define the number of clusters I want. Now, if you remember, I talked about having 5 offerings for 5 groups of customers. So I'm just going to input 5 there, and Tableau automatically profiles the customers into 5 segments. This is also called as customer segmentation, so as to say. One thing to note here is that the algorithm used by Tableau by default is k-means, which is an unsupervised learning algorithm. I'm not going to deep dive into what that is. I think if you are interested, I'd recommend you have you read on k-means algorithm as well. Okay, so that was about clustering, inbuilt clustering algorithms in Tableau. Here I have moving again, talking about the bicycle journey. If I wanted to predict the demand in the coming quarters, I would obviously want to forecast the numbers as well, right? Here I have my top 5 cities, which are the hotspots, and I'm looking at the trend as to how many bicycles have been rented out on a daily basis. And if I wanted to add a forecast, again, I'm simply going to drag my forecast into the visual. So all I'm doing here again is just drag and drop, right? And you could see that there is a forecast which Tableau popped up, and you could even change the forecast and just sort of customize your forecast with various options here. The forecast options let you sort of extend your forecast to further quarters, further days, depending on the level of data that you're looking at, right? Let me just keep it to 4 for now. And you could probably, if you wanted to aggregate it, the forecast at a certain level of granularity, you could do that as well. In this case, I've just chosen days. And you have some options to improve your training and test data set. Now, those of you who aren't aware of what training and test data set, please don't worry about that. It's all up to the data science team to figure that out. What we ideally want is a good data set that can actually predict your forecasting value. So you could sort of ignore your last piece of data. It could be your last month, last quarter, or last week. If you have null values, you could fill in with zeros. So that these things could be helpful in the long run when you're trying to forecast your numbers. It also, Tableau also sort of helps the users to define your seasonality and trend. You could choose additive or multiplicative seasonality or trends, right? And it Tableau also tells you descriptively in what's happening here and what it's trying to do as well. So depending on the model that you choose, it could be custom, it could be automatic, and depending on the model that you choose, it's going to give you the corresponding output as well. And lastly, it'll also, the user has the ability to define your prediction intervals. This is nothing but your confidence intervals. And now this is something that statistician or people who are aware of statistics can relate to. A 95% prediction interval or a 95% confidence interval would mean that your forecasted value, you will have a forecasted value that you see in the forecast here, and you will have upper and lower confidence intervals. And it's safe to say that 95 out of 100 times your actual value will lie between that upper control limit and lower control limit. So that's how you define your confidence levels as well. I get a little carried away when I talk about these things because it's very interesting to me per se, but you need not deep dive so much into it as well. It's just ideal to know how it's done with Tableau and the other platforms as well. All right, moving on to some simple what if analysis that you see. For example, here in this case, I'm simply trying to forecast my sales in the corresponding quarter or in the corresponding month. And this is a what if scenario, depending on your variables. Here I'm looking at churn rates and new business growth. For example, here nowadays it's a time of COVID and things are not looking pretty good. So you could probably have a look at a higher churn rate and a lower business growth per se. And depending on those variables, your what if figures, sales forecast figures are going to change. So that's a simple calculation. It's a table calc per se, table calculation per se that's inbuilt in Tableau that you could leverage to come up with the what if scenarios as well. Well, so these are some of the natively available features, inbuilt features that you could use in your advanced analytics scenarios. I'd like to show you how you could extend this further with the help of integration with platforms like Python and R. If you look at this particular dashboard per se, again, you're looking at here, so as to say it's a London city, if I'm not wrong, and you're looking at crime hotspots, right? Each of these spatial data points tell you where all thefts have happened, bicycle thefts have happened. Now, it's usually a lot here, right? And you could also see a yearly breakdown of the number of thefts that have happened and even the seasonality measure as well. Now, what's important for me or for a business or as an end user is to, again, sort of understand what are the hotspots or cluster or group them to understand how I can divide this spatial area into those clusters. Like we did with k-means clustering, the inbuilt clustering, for spatial data points, it's better to use an algorithm called dbscan, which comes from inbuilt packages in Python. Now, in order to do this, what I'll try to show you, I'm going to go to the sheet where we've made this up. We're going to use an inbuilt table calc wherein we pass parameters to your Python server, the TabPy server, and fetch results from there. If you notice carefully, I have already written the calculation for you. I'll just zoom in a bit so that you understand how the calculation is being made. You'll notice that this particular piece of code is what's being run on your Python server, right? And once that's done, what's actually happening here is Tableau is passing these. Sorry about that. Tableau is passing these variables into your Python server, and then fetching the results back and putting it back to Tableau and showing it to you visually. So this piece of code, just to explain, I'll just brief you what that is about. We're simply importing a NumPy package, which is a very popular package in Python, and as well the scikit-learn cluster as well. dbscan here is the algorithm that we're using, the clustering algorithm that we're using. This piece of line is what plots your graph. And if you watch carefully, here is where you're actually passing in your arguments. Your argument 1, your argument 2, argument 3, and argument 4. And those are nothing but your variables that you've mentioned here, right? Now, this also helps in changing parameters, because as data scientists and people who are really technical, they sort of work on the accuracy of your models. So you may need to change certain parameters to come up with a better accuracy for the model that you're trying to create. Well, so once you have this, before I continue, just one last thing. The script underscore str is nothing but the data type of your return variable, right? For example, if you're expecting that the output of this code is a string, then you pass it under a script str function. These are the available functions of, in Tableau. If you were to integrate or write a piece of code in which you integrate with Python or R, you need to put all of that under any of these, and that's how it's going to work. Okay. So having done this, I have the calculated field with me. All I have to do right now is put it onto my color shelf, and it's computing my layout. Now here I can see that the hotspots are the ones highlighted in orange. Now that's visually clear. I can fine tune my parameters. I could play around with my parameter here. In this case, it's a number of incidents. I can probably make it 40 or so. I'm just dictating the terms in the sense that If I see the number of incidents have risen up to 40, then I claim it to be a hotspot, right? That's what's happening. Before I continue, I'll sort of show you how exactly you are connecting to your TabPy server. You go to help and look at your settings and performance. And here you have manage analytics extension connection here as well. So you select that and you have two servers, rserve and TabPy. In this case, I'm using a TabPy. And your server is nothing but your local host, because that's where I've hosted my desktop and TabPy server on. And this is the default port here, 9004. I can even choose to test the connection. And once I click that, it tells me I've successfully connected to the analytics extension. Well, that's good, right? And once I have that, I can write my piece of code that I've showed you before and then play around with it on Tableau. Yeah, so that was an example of DP scan clustering and how you could integrate with Python. Here is another example, which is nothing but your sentiment analysis. I think most of you are familiar with this as well. Again, this is nothing but a piece of code that you write and integrate with Python. You leverage the packages in Python here. And this time we're using a package called Sentiment Intensity Analyzer here. Again, I'm not going to run you through the code. It should be a piece of code for your a piece of cake for your data science team. And yeah, that should be fine. So here, what I can see is in Seattle, people are more positive towards your offerings with if you compare with the other cities, right? That's one of the insights that I can see right up front. This is just an example. You must be already aware of sentiment analysis done on social media, on the tweets, which all this could be very powerful depending on the use case that you're trying to address. All right. One other example that I can think of is your classification models. The classification models is again, it's a supervised learning algorithm, machine learning algorithm. One of the key things and one of the key challenges rather that data scientists face in today's world is again come up with that model that can give you very good accuracy at the same time not do an overfit or an underfit model. Now, if you do have so many models in place, and if you have the option to toggle between the different models that you have created, you could really look at the accuracy that you have, right? And this is exactly what you see here. You're actually passing a parameter, the model as a parameter into your TabPy server, and you're trying to see which is the best fit model and how do you want to go further with it, right? Now imagine you're putting this in the hands of a business user, and the examples that I've shown you here, right, with sentiment analysis and clustering algorithms. A business user or end user who's not technical per se, he won't be able to relate to your Jupyter notebook or your Python piece of code. So it's very important that you show the message, you convey the message properly, and also maintain that level of interactivity or add that level of interactivity that an end user can leverage with Tableau. All right. Now, before I just wanted to show you the same process with R as well, so that you have a complete understanding of how you would connect to your R server as well, right? So the same drill, I'll go to my settings and performance, manage analytic extension connection. And if I were to connect to my R serve, I'm going to select R serve there. The server remains the same, but the port is different. The default port is 6311 in this case, and I'm going to test my connection. All right, it says I'm successfully connected. Okay, that's fine. And see, I could just show you that my RStudio is running here. So I've run the RServe here. It's just 2 lines of code and you'll be up and running. Okay, so once I have connected there, let's assume the case of a superstore, a retail store, and I want to have a look at my profits across time. So I bring in my profits, all right, and let me bring in my date and change this to a quarter. Yeah, that's good. Let me just make sure my our servers up and running. Yeah, 6311 test connection. Yeah, I'm successfully connected. I just wanted to re-verify. All right, so that's good. So here I have each data point tells me the profits that I've made in each quarter within my retail business, right? If I wanted to have a look at my outliers, something that's really off the charts, uh, what I could leverage is use R integration, use inbuilt packages in R, and sort of try to understand or quickly understand what my outliers are. One such package is called MB outlier. I know I'm not going to talk to you about what MB outlier is, but I'll just show you the piece of code again that I've already written down there. I'm just calling the MB outlier package and calculating my I'm classifying my outliers per se. And here I'm giving it a condition. If it's an outlier, then I've termed it as an outlier. Otherwise, it's just normal, right? And the very classy way of showing this on Tableau is again just a drag and drop and put this on my color shelf, right? Here I see two outliers. I'll do a bit of formatting as well. Let me bring this to my shapes so that it's more visible. Yeah, that's perfect, right? So just with a little drag and drops and clicks, I'm leveraging the powerful analytics that R has, bringing it to Tableau, and then leveraging Tableau's powerful interactivity and flexibility to showcase what's happening. Now, if I want to drill down to a month level, I could do that. From a quarter to month level. Yeah, there you go. Now it's at a month level, and I can see at a month level what are my outliers. So what in essence is happening is it's fetching a query back from your R platform and bringing it to Tableau and then showcasing it to the end user. Isn't that cool? It's just amazing as far as I'm concerned. All right. The last piece of bit that I wanted to talk to you about is the extensions gallery. Now, Tableau supports a lot of extensions. Extensions are nothing but the third-party applications that the Tableau partners built. They're part of the Tableau developer community. And there are a lot of extensions. I think it's worthwhile to go through the extensions gallery as well. The way you do it is you bring on your extensions here, extensions you could see down there, and just drag and drop it on your dashboard, just as an example. If you have extensions downloaded on your system, you could go and choose my extensions. Otherwise, just click on the extensions gallery, which will take you through the entire list of extensions that Tableau partners have built to date. So all these are the different extensions that are available. It comes along with the license that you will be purchasing with Tableau. One of the extensions that I showed in the PPT was Data Robot. So maybe I can just show you what that is about. So this gives you a description of exactly what it does, who has built it, why this is used, how it adds value. In this case, it tells you what's happening behind. Like it sort of helps you derive insights from your data quickly rather than having to spend time manually. Right. So it's worthwhile. I'm not going to deep dive much into each of the extensions again. Please do have a look at this. It's actually very powerful. All right. Okay, so then going back to my slide. Yeah, there you go. Yeah. So one thing to note here is that all the things that you saw today was on my Tableau desktop. Now you could leverage the same capabilities in Tableau Prep as well. Now, for those of you who are unaware of Tableau Prep, it's that tool that you use for combining, shaping, cleaning data, and all these extensions, the Python and R extensions are possible in Prep as well. But then the natural question comes: when do you use Prep, and when do you use desktop, right? So if you have issues with respect to scripting, if you have issues with getting the data up and running before you start the analysis, you use Prep, right? That's what. If you're fetching or enriching your data, If your output is in multiple columns, you have humongous volumes of data, and if the script is very complex, you go for prep. On the other hand, if you're just looking for machine learning algorithms, data science algorithms, you just want to, you would go for Tableau Desktop, right? And obviously, if you want to add more interactivity with parameters, you would go for Tableau Desktop. Now, that was a gist of what I wanted to showcase today. This is something, this whole space of data science is actually emerging, and the possibilities are humongous. So I'd encourage you to just have a look at these extensions, these capabilities, and complementing solutions that you can have with Tableau. And I hope it turns out very fruitful for you as well. So if you have any questions at the moment right now, I'll be happy to address. Okay then. Thanks for attending. Just reach out to any of the mentioned folks from my team. So our email addresses, I hope, are with you. Please do reach out to us and do let us know your feedback. And yeah, so that's it. Have a nice day and thanks for attending. See you in the next session, hopefully.